So we will start with the testing. And again, one of the critical components of the software design is testing the software that you have came up with. And in testing, you can test many different things. However, it will include a complete program with various inputs is one of the key things that you would like to see. So you will test your program with various inputs, possible inputs from data range, and then you would like to see whether your program is performing correctly according to the conditions or the requirements that you have. You will also perform a human or computer assessment to see whether your program is performing correctly according to the specifications. So you can start before coding your test sequences so that you will check whether your design is valid so far. If you find a problem as early as possible, obviously it's better to check and easier to fix any problems. So our goal is to find any errors, any bugs that are possible in your implementation, and if we fix these errors, we will say that hey, our application is performing in 99% with perfect running confidence and so on. So you can be more confident about the program once you once you perform the certain testing sequences. However, obviously you won't be sure about your application being error-free at the end. Always there are errors that are still cannot be found. So when do we stop testing? The conceptual answer is never. So you keep testing and testing and testing until even your program is out there with the users being using the application. However, the basic answer is whenever you run out of time and you have to deploy your software, for example, for your assignments, you have to return the project requirement and then return the code to the instructor or to the TA. Then that is the deadline for the testing. Sometimes if you don't have sufficient time, it may cause a lot of problems on your end, because in the programming assignments we have been testing with the projects or programming assignments we usually see that if you don't do enough testing, you will face a lot of errors in your program. So if the best answer is that when you are willing to risk that an undiscovered error still exists. So if you're willing to take the chance that hey, there could be more errors, I can't continue on testing from this point on, that's where you will probably stop. And that's the that's the way that is used in industry as well, because you can't continue forever for testing the application. So you have to stop somewhere. When you look into testing, you have reviews, which can be performed by a human being or a program again, but most of the time reviews are done by the human beings, and you present your design or code to the others. This way you will think more carefully about it while you're presenting, so you have to convince the audience you have, and you have to convince them your design is good, and also it will provide an outside perspective so that if you don't see some problem, they may probably see it in an in an outer look. And these are called inspections or walkthroughs as well. So if you want to test your application, what you would like to do is that you create certain test cases, in which case most of the time you would like to have a test case that is broad enough such that you test different various aspects of the code. So let's say you take input from user as integer values. You would like to have a different wide variety of different test cases, test inputs, to see if you satisfy the conditions that you're looking into. So you have a quality assurance department to perform these tests in the companies when you go. The defect testing is performing the test cases on your application or your program, and whenever you find these, you will obviously fix them. And however, if you fix an error, it's possible that you may create other errors aside from this fixing procedure that you have. So you rerun your previous, tests again over and over to see if you created other new bugs when you're correcting the found bug. So this is called regression testing. You go iteratively over and over with updates on your code. However, obviously you can't create as many cases as you like for all the possibilities. So you try to divide it into sets of test cases and maximize the ability to find from each testing domain. So there are two types. One is black box testing. Obviously, the other one is white box testing. In the black box testing, as the name suggests, what could it be? Black box testing. So you assume the program or the application as a black box. You don't know the internal implementation. You have no knowledge of how it is done, how it performs. You only have an input and then you only generate an output from that. So basically it is a box which you have only information is related to the input and output. So you use that information regarding the input and output and see if you can come up with various test cases such that if this black box is performing its goal in the perfect way it should be. So you don't consider the internal logic at all, and based on the input and output you will see whether it will cover every every problems that you may have. So your test suite will cover all equivalence categories. So you divide your, for example, if your input is taking an integer, what category you may have is that, for example, one type of category. You could think of it as the negative values. You can think of one category, for example, and then you may think as positive values, and then you have the 0, for example, another category which may be distinguishing different test cases that you would like to test your black box on. And then based on the output you decide whether it performs correctly. However, in white box testing, as the name suggests, you have an internal structure knowledge which indicates the logic of the execution of the program. So if you know the logic, if you know the paths that this box can follow, so if you have, let's say now this is a white box, you have multiple paths that you can go to the output and see what it executes. So you can track all these different test cases based on these paths that you may have in the internal implementation. Such as, let's say, in the previous example we have seen with 3 methods, you see that it follows one method and then it calls those 2 other methods and so on. So you would like to follow that path and try to see if it generates any problem there. So if you recall, in our translate pig Latin language, we had the translate, and then we had the translate word, and we had the 2 different methods, begins with vowel, right? And then we have begins with, what was the other one? With blend. So these are the 2 cases. So you would like to have 2 test cases, in which case you would like to test this path, and then also that is going to test this path as well, to have a coverage of all potential errors that you may face in your design. So this is called a white box test. Again, it indicates the internal implementation, so you have an idea how errors may occur. So this is the chapter 6 concepts that is covered with the programming part of the book, and then we have the GUI design and layout components that is going to be the rest of the class today. So in GUI design, you have to design the software such that user's problem is going to be solved in the most effective way. So GUI designer should know the user, what type of user you have. For example, the user may have no idea about the program that you're running. Prevent user errors while having the user input. For example, forcing the user to select from multiple instances. Let's say if you have 3 different choices, you don't want the user to enter a text and then select that one. He or she can write 1, and then he or she can write 2 or 3. Instead of this, what you would like to have is that you have selections which the user must select from. For example, a radio button, which the user selects one from. So this will prevent user errors rather than letting the user type the value by him or herself. So optimize the user abilities. So you would like to allow user to do as much as he or she can, and then be consistent. This is important also in real life. You would like to have error messages appearing on here and there in the application. You want them in the same place as much as possible, or you would like to use the same color for indicating same thing. If you're reporting something, be consistent with what you're reporting to the user, and ask the things that are asked to the user in the same way. It will be a lot more appealing for the user access. So know the user. So you need to understand the user's true needs, and then what are the common activities that a user do. For example, in a machinery house that is using a software, you would like to design your software such that it should be easier for that operator to easily access the buttons and start a process, for example. And what are those common activities? You have to know that. And also, for example, if you're trying to teach a programming language, then you would like to design your software to teach a program. You have to design the software such that whether this person knows a little bit of programming or he or she knows no programming at all. That makes a lot of difference. So you would like to have your software considering those facts. For different users, you may want to have different scenarios. So you would like to have both an expert user interface, which will be easier for the expert, and also you would like to have a basic implementation, which is for the basic users. So that will be good for both users. And also user errors, as I said earlier, you would like to design your interface such that you eliminate the potential errors entered by the user. For example, if you have few valid options, you would like to use radio buttons, as I said earlier, rather than an open text field usage. So you also would like to give error messages as appropriate as possible. So you also would like to have user abilities optimized. Knowledgeable users are sometimes called power users. So you would like to design your software for the power user to be efficiently able to implement it. Or also wizards to walk a user through a process, which will be the basic user's way of implementing using your program. So also facilities to help the user to indicate what is done and how it is done should be included as well. Again, be consistent. So you would like to have consistency overall your application. Colors should be used consistently, and then screen layout should be consistent from one part of the application to the other parts. And also error messages should be in the consistent locations. So when you consider the layout of the GUI components you design, you would like to have a layout manager to use. So there are already predefined layout managers to place things into the screen. This was asked before in the class. So if you would like to align things on the same line or on the same column, or if you would like to distribute them in a grid, so there are certain layout managers provided. In AWT, you have these layouts: flow, border, card, grid, and grid bag layout. I will go over some of these. And then you have box layout and over layout that is defined in the swing library. So if you would like to have your screen look in a certain fashion, you can use those. And a combination of these different layouts is also possible. So if you look into the layout, every container that you have, for example, JPanel has a certain layout manager that it is using for. For example, in the JPanel, what we do is, if you remember, we have the components on the container. Listed one after the other one on a row fashion. So if you have 4 buttons, let's say, what you do is that in the panel, they are listed like this. So you start from the left and then goes right and goes on to the next row and so on. So this is the default layout that is used in JPanel. However, you can, you can modify this and have a certain rule that it will obey. For example, you will design it such that north, west, south, and east fashion, layout could be implemented. And we will see different versions of these. So you try to adjust the layout according to the needs of your container. So for example, in JPanel, you have panel new JPanel, and then I have the set layout and put it into the border layout. So we will see what border layout is going to show. So layout demo example is a good one to see all these different cases one after the other one. So let me go that. What was the name? Intro panel and the layout panel. So as you can see, this is the layout demo we have seen. And if you look into the code here, we have the tab pane. So we have a frame, JFrame layout manager demo, and then we have the close operation. And we have the JTab pane, TP, which is going to create a tab pane. Tab pane is basically this pane that is composed of multiple tabs. So you add more and more tabs onto your tab pane according to your needs. And in this case, we have the tabs that are intro, which is the intro panel that is created first, and then the flow panel, and we have a border panel, and then a grid panel, and then a box panel. As you can see, these indicate the titles that are on the top of every panel. So these are the titles that are given, grid box and everything. So we have 5 different panels added onto our layout manager. And let's go into the intro panel. So this is basically a tab pane with those panels added. When you go into the intro panel, we have the intro panel. As you can see, basically it has it extends the J panel, and then what do I have? I have the color background green, and I have the 2 labels, new J label, and then another label that is showing the same thing. So I have these created and added. As you can see, those 2 labels are added onto the panel, intro panel, which is the first panel that I have. And then I have another panel, which is the flow panel, and then I have border panel, grid, and box. So these we will see one by one. So let's go into flow panel. So this is the actual default layout that we have been seeing so far. So it is basically the flow that I explained earlier. So you go from one row from left to right and then continue on the next row as you have additional components. So flow layout puts as many components as possible on a row, then moves to the next row. This is basically the structure of the flow layout. Rows are created as needed to accommodate all of the components, and they are displayed in the order they are added. So as you add them, they are displayed on that order, based on that order. Each row of components is centered horizontally in the window by default, but could also be aligned left or right. So they are aligned in the horizontal fashion in the center. However, you can set it to left or right based on the needs. So you can also set the gaps between different components explicitly. So this is the flow layout. As you can see, these are the buttons that are added one after the other one, and this is the order they are added onto the panel. So this should be, as you see, all of them fit into the same line, and if you make this, if you resize it, it's going to adjust the alignment or the distribution of the buttons onto the panel, and as you can see, it is centralized on each row. So if you go into the flow, so I will go into flow panel. So again, we have flow panel extends J panel, and then I have the set layout, new flow layout. So I set the layout of this to the flow layout, and the background is green. I have the buttons added in the order of 1, 2, 3, 4, and 5. So again, if you change the order, their placement will be also different since they're added in this order. So if you update the order, it will change it. And if you go into the border, so this is the border. Basically, in the border layout, what we have is that we have the center, we have north, south, east, and west. Okay, so these are the components that you can add onto these locations. However, you can you can only add one component into one field. So if you would like to add 2 buttons on this one, if you add 2 buttons one after the other one, it will only show the last one that is added. Okay. So let's see and go into the border layout. A border layout defines 5 areas into which components can be added, as I have said before. North, south, center, west, and east. You can add the things into those places. Each area displays one component, so you can only have one component displayed in each area. And if you enlarge the size of the thing, it is going to adjust the sizes. However, if you add nothing to the outer areas, they take up no space, and other areas expand to fill the void. So if you omit some of the components, such as north or east, it will expand according to the remaining parts of the panel. And so we expand, as I said earlier, according to the needs. And let's go into the border panel. This is basically the same thing. So I have the new border layout, and I have the buttons created again, and I add this button B1 onto border layout center, or north, south, east, and west. So they are added into the corresponding fields. However, if you would like to add 2 buttons, button 1 and button 2, into the center or north, the last one that is added will be shown on the actual page. Okay. So what if I would like to use 2 of the buttons on the, for example, north? How can I do that? So let's say if I would like to add another button. So I create button 6, right? So if I would like to add another button onto, let's say, where is this located? So button 5 is on the, B5 is on the west. So if I would like to add both button 5 and button 6 onto the west location, how would I do that? Since only one component can be added. If I do it this way, add it here and say that add B6 onto west, obviously only button 6 will be shown. However, if I would like to show both of them at the same time, well, basically what I would need is another container, right, which will hold both of these buttons at the same time. So if I create, for example, a panel, right? Okay, let's execute this. So button 6 is actually replaced button 5. Since again only one component can be shown there. If I want to, however, include both of them, how would I do that? Again, going back to the border panel. So I have these both button 5 and button 6. What should I do? I can have a J panel, right? New. JPanel panel, and then I have a new JPanel, right? And then what should I do? Panel, then I would call add, right? B5, and then I will add B6, right? So I created this panel and added those two buttons. And what will I do? I will just add this panel onto the west part of the border layout. Hopefully it will work. So this is how it will appear here. Why is it shown like this? Because it has the default layout for the flow, and it is going to put them into the, into one after the other one. And if you want to set a preferred size, you can do that. You can adjust the layout according to different, things you have. Again, the background is not set, properly. So if you want to adjust that, you can do that too. Okay. Any question? So if we go back, this is the border layout. So by using these layouts, you can come up with different, views as your needs, and you can adjust certain things into certain locations and, move different buttons to different locations according to your needs by using one panel inside another panel and, generating a hierarchy of panels, and so you can generate the overall result as your needs. So grid layout, it's a container, as you know, what's a grid? Grid is kind of something like this. So you have, a grid that is composed of mesh locations where you can put any component into any location or any place in the grid layout. So one component is placed in each cell of the grid, again one component, and all cells have the same size. As components added to the container, they fill the grid from left to right and top to bottom. So you start from this location and then continue on each row and, fill the grid cells as you go from one row to the next one. The size of each cell is determined by the overall size of the container. So let's go into and see the grid panel. If you see the grid panel, we have 5 buttons, one added after the other one, and then, as you see, since we have 5 buttons, they are occupying the area that they have there. So when you, adjust the size of the overall, layout, it is going to update their individual size. So let's go into the code here. Grid panel. So I have, again, the same thing. It's just the only difference is that you define your grid area by giving grid layout 2 by 3. So you have, 2 rows and 3 columns. And for each grid cell, you add the buttons according to this order. So the first one goes into the first cell and so on. Okay?
Eğer hocam butonlara bir size verseydik, daha sonra da ekranla oynama yapsaydık, dediğimizi yapar mı?
So you mean whenever I resize it, is it going to
change according to the motion of the mouse click?
It's going to. You can set the button sizes, but they're going to be only the preferred size. So if it is going to be smaller than a certain size limit, then it will, just resize them and make them smaller as much as possible. Again, you set only the preferred sizes initially. However, there are certain methods which you can call just to have them fixed, and I don't want it to be resized or anything. You can do that. So, for example, once I have this panel resizable, you can make it such that it's fixed and nobody can play around with the size or so. Box layout. So it's a box that is, that can be organized in horizontal or vertical. So it could be in one row or in one column according to, again, your needs. And you place the components top to bottom or left to right in the order which they are added. So if you have a, order of items that you add, they are going to be added. If you arrange them in a vertical fashion, the buttons are added in this way, in one column, or if you organize it in a horizontal fashion, then you have the buttons added, for example, in this way. So you can set, you can set this horizontal or vertical according to the, code you would like to have. So let's see this box layout. So this is how it is going to have the buttons. So you may find that why these are fixed, why these spaces are fixed and this one is enlarging. So that's basically because of the box layout. I will show you the code and it will be more clear. So going back to the... So this is the code for the box panel. Again, it extends the J panel. So I have the new box layout and then I create this object. And box layout y-axis, so it's in the vertical box, and I have the background color green, and I have created those 5 buttons again. And this is basically where we're performing the spacing. So I have the first button added, and then I create a rigid area, which is a constant sized area, which has a dimension with 0 to 10, right? And then I have the button 2, which is going to be added afterwards, and I have a vertical glue, which is basically the glue between these 2 buttons. And as you enlarge the space, it is going to be enlarged from this portion. And you have the button 3 and button 4. And if you have, you have again another area that is a fixed size of 20 pixels, and then you have the button 5, right? Since this is indicating the size in the size in the vertical or y dimension of the space that you would like to add there. So that's basically the 2 rigid areas. This one is the first rigid area, this one is the second rigid area, and then I have a glue between these 2 buttons. As I enlarge my buttons, it's going to enlarge from that portion. So this is, invisible components can be added. One invisible component is the rigid area with a fixed size, and then a glue that specifies where excess space should go. And a rigid area is created according to use of create rigid area method. And then glue is created based on the create vertical glue method. So this is basically about the box panel. So if you would like to add borders around the swing components, you can define those, and you define how they are going to be in terms of the shapes and in terms of their properties. The border factory class contains those static methods, so you can use the set border method to set the borders of buttons or things like panels or anything you can think of with a border can be adjusted using the borders. So we can have an empty border, so there's only a space between the components, nothing except a space. A line border, just a line around the border. An edged border, it creates the effect of an edged groove, so you have kind of a edge around the button or the panel or whatever you have. This is the edged border. And you have bevel border, so you can have a bevel that kind of has the feeling that the button is above or button is lowered. So that's also a border that you can select. A title border which puts a title. A mate border so that you have a size that indicates the size of the line around the border. I will show all of these in one example. A compound border, which is a combination of those borders. So let's see the border demo.java file to make it more clear. So this is the example. So we have a line border. If you look into here, you have the line surrounding it. You have the etched border. So it's kind of an etching around the border. And raised bevel border. So the button looks like it's raised. And you have a lowered bevel border as if it is lowered. And you have a title border. So you have a title on the left. And you adjust the alignment in the title border so that it shows the title on the right. You have a compound border, which is combination of, I don't know exactly, line plus probably bevel raised or something. I don't know exactly, but we can see the code. And in the mate border, what's the difference between the line border and this one? No difference? So the sizes of the lines around the border is different. So that's the mate border. So let's see the code in individual borders. So this is the first one. Panel set layout, grid layout, 0, 2, 5, 10. And then I have the empty border that is created with 8 spaces on each one of them. And then you have the first panel that has color red and then a size of 3 pixels on the line, right? So this is going to create the border with the line color red. And then you can set the second one, etched border, create etched border. So it creates the border as an etched border. And then you have raised bevel border. So you create the raised bevel border. Again, all of them are part of the border factory. So you select the corresponding border. And you have a create lowered bevel border. You have create title border. So title is the title that is going to have on the left corner. And in the second case, if you remember, the title was on the right hand side. So you set the TB, the title border TB. And you set the title justification to title border right, so that it is right justified. And you set the border to this title border. And it's going to adjust the panel 6 according to that. You have the panel 7, which is going to have border 1, and which is line border, and then the other one is etched border. It wasn't actually bevel border. So if you remember, this was a combined border, compound border with B1 and B2. So you can combine different borders as you like. And the mate border is actually create mate border, and then you give the sizes of each edge, each border. This is top, left. Okay, you start from top, and then this 5 is left, and then you have one bottom and then right bottom. Okay, so this is basically, you start with this part, top, you give 1, and then you have the left, you give 5 as its size for the border, and then you have 1 and another 1 here. So it's in a sense counterclockwise rotation. And as you see, you have the last panel created here, and we add all those panels one after the other one on top of the main panel, and this main panel is shown here on the frame as the main panel. Okay, so going back to here, as you see, we have an 8 by 8 border that is left as a space on the main panel. This is where you see the outermost panel's border, and that is created here. If you go back to the top, this is where it is creating the empty space or empty border at the beginning without anything there, with 8 on both sides of the, on all sides of the grid we have. Any question? So these are again components which you can use in your projects, and this will be really useful for your designs. To summarize what we have covered in chapter 6, we have seen how the software should be developed, and what are the activities that are involved in software development, and how to identify the classes and objects, and the relationship between these objects are also given. And we have seen the static modifier, how to write interfaces and enumerated types, and then method design and method overloading. And we have seen additional GUI components in today's class. So we will have a quiz now, and we will stop the video now.